Well, the first thing I'm going to do on this L20B, this has about 100 miles on the rebuilt engine, is I'm going to swap out the plugs for non-resistor plugs. So the stock ones are BPR 5ES. The 5 indicates that it's a resistor. So if you want non-resistor plugs, you just get the BP 5ES, which means there's no resistor. These are about 3.2 ohms. I did not measure these, but I'm going to guess that they're probably around 5,000 ohms. And the resistance in the cables to the plug eats up 99% of what leaves that coil, under the guise of eliminating radio interference. But with just non-resistor plugs, you get almost none, except for a few ticks on a CB radio, and it's very difficult to even find on the AM band. So in any case, I'm going to be putting in the BP5ES plugs. These got to stop the recommended gap. I'm going to be cutting these J-straps off, and I'm going to have a very large gap. I might cut these maybe off about half because I want it exposed, and I want the plasma blast to be facing the piston, not have to go around that J-strap. And then the other thing I'm going to do short term real quick is this is one of these Pertronics things, a Flamethrower 3 or something like that. But the reason I got these is because the input winding is only a couple ohms, and which is suitable for a high-speed capacitor discharge, so the rise time is really quick. So I'm going to be replacing that. Today I ordered some non-resistor cables, which are not completely necessary, but with the CDI it does work pretty good. Getting those from Granatelli, about 70 bucks delivered, and they're going to have basically 0 ohms of resistance end to end, and I'm not worried about radio interference or anything because there's no real electronics on this car to mess with, so I'm not worried about that. The plasma is going to bypass the distributor and the cables, and it's going to go straight to the plug. But that initiating CDI spark, I want that to at least be as strong as possible. So non-resistor plugs, non-resistor cables, a low impedance, a low resistance ignition coil, and that'll be the first step. And then of course I'm going to modify the strap on the non-resistor plugs. I'm going to cut these about in half so that that's fully exposed, and I'll have a little bit wider gap. And once that's done, then I'm going to be putting a Street Fire MSD ignition module on it for capacitive discharge ignition. Each discharge is about 98 millijoules. 98 millijoules is the size of the amount of capacitance in the capacitor in the CDI. It's somewhere around 450 volts, something like that, at very low capacitance. And then once that's up and set, then the next thing is to add my high voltage diodes from the primary of the ignition coil, which is going to be touching the positive of the capacitor inside of the CDI. And then I'm going to take the other end of the diode and I'm going to run it straight to the top of each plug underneath the cables, and that'll be the plasma ignition, which greatly extends the lean burn limit. Then so that'll be the first step. Put the plasma ignition on it with all low resistance parts, and that'll be step one. So here's the L20B. What I have here is, these are the cables that came with the car. These NGKs, looks like probably 8mm cables. I just have an ohm meter on right here showing 5.53K, which is right about where I expected them to be. Usually the spark plugs are kind of in the same range, but I did put non-resistor plugs in. So these cables are 5,500 ohms, which is way too much. And by the time you go through the ignition coil cable to the center of the distributor, and then it's distributed to the spark plugs through all this resistance here, that's killing 99% of what leaves a typical ignition coil. So what we're going to do is we're going to put these Granatelli ones on. This is the part number for this engine, and we'll see if they got that listed right. They had some listed for an Audi and some listed for something else. They didn't have one specific on their website to a Datsun, but it's compatible, and we're going to find that out. These wires are non-resistor, which means basically about close to 0 ohms as you can get. And these cables, solid steel core, and you can see this little ferrite ring around it. What that does is help eliminate the RF interference. And you can even see on here that they're claiming OBD2 computer safe, which means any kind of RF from a non-resistor cable is not going to interfere with computers on a car. So I don't have to worry about it on this car because obviously I don't have a field computer here, so I don't have to worry about it. And also the other thing that I want to mention is that when I put the plasma ignition on here, I'm having the capacitor discharge directly across the plug, bypassing these cables, so I don't really need non-resistor cables, but I do want as strong spark as I can get. And so that's why I'm going this route. So in any case, I just want as low impedance as possible. And again, that coil over there is about 1/3 of an ohm. It's about 0.3 ohms on the primary, which means it'll have a really fast rise time. So this cable is measuring at 5.53k ohms. And if I look at one of the Granatelli cables here, I really do like the quality of what they do. So for example, here's one of the cables right here, and so I'm going to put this in one end here, and the other end right here. 0.6 ohms. I don't know if this is perfectly calibrated, but we're looking at, less than an ohm compared to 5,500 ohms. So that's a big difference. So if you want non-resistor cables, and it has a built-on little ferrite ring here to eliminate the RF, Granatelli is where you can get those. So you can see that's very low resistance, and when coupled with a low impedance primary on a ignition coil and non-resistor plugs, which are going to have about the same resistance here, then you have about a low resistance ignition system as possible. So this is going to work out really good. So I'll go ahead and get these cables on. Well, it's the spark plug cables. Dark blue ones are the ones that were on the engine. The lighter blue ones are the Granatellis. It's 4312. And then the ignition wire from the coil. Pretty close matches. There's one that's about it's maybe about 7-8 inches longer than it needs to be, but for the most part it's a pretty good match. So we'll go ahead and get that all put on. Okay, so we got this MSD installed on this Datsun here. It's a L20B engine. So this is really an inexpensive module and works really good. 4, 6, or 8 cylinders. 4 or 8 cylinders, you want to make sure you cut these blue and red loops. Okay, so the wires we have coming out of here on this side, out of this plug here, or let's start with this one. This gray one right here is basically for a tachometer, and I just have this bundled up here, and I'll put that on a tachometer later. The green and purple wire is going here because the guy who did this distributor, he replaced the points and put a magnetic pickup in there, so it's basically an electronic distributor. And the output to that, each time the rotor is turning, there's a magnet every 90 degrees, and it sweeps past a magnetic sensor, kind of like a reed switch, that makes contact, short circuits, and what that does is closes the loop between these two wires, and that triggers it. So that's how you fire it. This white wire here is another way to fire it, which is another type of electronic distributor, and basically you connect that, and the distributor will drop it to ground, and each time it's dropped to ground, then it'll fire. But for this setup, with this magnetic pickup in here, these are the wires that you want to use. The big red wire here is going straight to the battery. You can see that right here. The fat red wire goes straight to the battery, positive, right here. That's this wire right here. And this skinnier red wire is basically what would go to the key. So when you turn it on, that connects this wire to the positive of the battery, and that gives power to the unit. There's a black wire coming out here, and I basically just have it under this screw right here onto this ignition coil mounting bracket, and that's going into the body, and it has a good ground right there. And then the other wires are, there is a orange and black one. I believe the orange one goes to positive on the ignition coil, and the black one goes to negative. And so it's really simple, and that's all there is to the entire installation. The wires that were on the ignition coil, you don't want to add them in parallel. You want to remove the originals, tape them up or something, and mount those somewhere, because you're not going to need those, because this supplies the capacitor is what's discharging to the primary of these coils. And so there's different settings. Instead of dip switches, this model has the rotary dial, which you can do different types of RPM limiting and all that kind of stuff. It's just set at factory right now. This is actually a refurbished unit, guaranteed from the MSD factory, that I got on eBay. So this one was only maybe like 115 bucks, something like that. Normally it's about maybe 155 on Amazon. And so what I'm going to do is I'm going to turn the key on, and but first, this is a MSD 5520 Street Fire. Street Fire is the MSD kind of budget brand, and but it works really good. I've used this on many cars, never have not gotten it to work, and later we'll be converting it to plasma, and I'll show you how to do that. So this is the MSD 5520 capacitive discharge or multiple spark discharge module. Got the Flamethrower 3 from Petronix, which only has a 0.3 ohm primary and only about a 7,000 something ohm secondary, which is, so with that low of resistance, you get a really fast rise time on a cap discharge going into it. And that coil is about maybe, I don't know, 55,000 volt output or something like that. And so you want the low resistance. I'd recommend the Flamethrower 3 by Petronix. And then the cables are the 0 ohm Granatelli cables. And then I have basically the resistor-free version of the specified NGK plug for the non-resistor versions of the plugs. And so if you just wanted a regular upgrade without going all the way to the plasma, you're really not going to be doing much better than this. The next improvement, if I want to do anything on just this, would be to open up the gap a little bit, and that's about it. Or actually cut the J-strap on the plug back. So what I'm going to do is I'm just going to put this camera on a tripod here. I'm going to go turn it on, and we'll see how easy this thing starts up. And this is a 77 Datsun 620 pickup with a rebuilt L20B. I'm not the one who rebuilt it. Who I bought this truck from, he had it rebuilt. And it's got a Weber carb. I think that's the only modified part on here other than the distributor being electronic. So we're going to start it up and let's see how easy it starts. So you can see it starts ultra easy. Just got to brake. As soon as that starter kicks on, it's running. And that's all there is to it. So the next phase is going to be, since the capacitor is in the MSD module there, and this capacitor, see the way it works is normally the capacitor is going to be charging up. This 98 millijoules is what's in the 98 millijoules is the joules of potential energy in that cap. It's about 500. It's close to about 500 volts, maybe 450 volts or so, and only about maybe 2 microfarads, something in that ballpark. And so normally, instead of a 12 volt battery discharging into the, or being applied to the primary or the secondary, and to get the high voltage spark, what we're doing is we're dumping hundreds of volts into it instead of 12 volt, and that's how you get the increase. But it's also a capacitive discharge, and so it's a little bit different than just a regular 12 volt battery discharge. You're getting a more abrupt impulse into that, and the rise time is going to be really quick. You're going to get a really high voltage output of that coil. With the CDI, I don't know, it could easily be 70, 80,000 volts, something like that. And then with no resistance in the cables, or, you know, bare minimum, they're obviously not superconductor cables, but they're, you know, right around an ohm or something like that, or less. Whatever I measured on it before, like maybe 0.7 ohms or something like that for these long ones. So we're looking at 1 ohm from here all the way to the plug, and the plug only has maybe 3 ohms. So from the ignition coil to the plug, we're looking at about 4 ohms. And so what I'm going to do is take the cap in here, which is normally, you know, hundreds of volts, and normally it's thought to be impossible to jump this cap across a spark plug gap or any kind of gap, because 500 volts is not high enough to break the so-called dielectric resistance of the whatever's at the gap. So that's why you need high voltage to be able to jump the gap, like what's coming out of an ignition coil. But what I'm going to do is I'm going to route the capacitor through some high voltage ham radio switching diodes to the top of each spark plug. I'm going to bypass these cables, and I'm going to connect from the capacitor positive, which is still going to be dumping to the ignition coil. And normal old school CDIs was a 1 capacitive discharge per trigger, which means each time the car needed a trigger or needed a spark at the plug, what it would do was discharge a capacitor 1 single time, and that was it. But with the multiple spark discharge, the circuit in here is quite a bit more sophisticated and faster, so it's able to charge up, dump a capacitor, charge up, dump a cap, charge up, dump a cap, and it's able to do that about 6 or 7 times when you need 1 spark, which means you got a spark at the cylinder going, you know, multiple times throughout more degrees of the ignition cycle, which means you're going to be burning more of the fuel. So it does make a difference. It's not a huge difference, but what I'm going to do is take that to the next level with my patented plasma ignition circuit. So what I'm going to do is connect from the capacitor. It's going to the coil, but I'm also going to connect the capacitor through a high voltage diode to the top of each plug. What that's going to do is allow the cap to discharge to the coil, and as soon as there's just a bare minimum spark at the gap, see, the spark ionizes the gap and makes the gap conductive. So what that means is that the capacitor doesn't see a high resistance gap anymore, and you get a low, relatively, you know, this is high voltage low current, then you get a low voltage high current punch at a negative resistance. That is an accelerated discharge on this cap faster than you're normally supposed to be getting, because the high voltage of here is pulling on the high current here simultaneously over a gap. And so the low resistance or the negative resistance effect does not just happen at the gap. it's actually happening over the circuit into the capacitor, and I've done multiple experiments to kind of give some evidence of that is actually what is happening. And I've done all those presentations and wrote the book on the theory and all that kind of stuff at ignitionsecrets.com. And so anyway, as soon as this regular spark goes over the gap, the cap discharges, and it's such an instant disruptive discharge that when you look at a CDI or MSD spark at the spark plug, it normally just looks like a little more enhanced spark, but it's still the same type of spark phenomenon. But what I'm able to do is make it look like a little ball of white sunshine right there at the gap that's really, really loud and really, really bright. And what that does is it's so fast and disruptive that any hydrocarbon molecule that is in which water is a hydrocarbon molecule, or it's a hydro molecule with hydrogen in it. So any time that the plasma is in contact with a hydrocarbon molecule or water moisture, it instantly dissociates and rips that hydrogen right off from it. Then it ignites that hydrogen, and that hydrogen has a fast flame propagation speed and high temperature. And what that flame does, the hydrogen flame, is it penetrates the rest of the combustion chamber and more thoroughly ignites the fuel. And so normally around 14.7 to 1 parts air to fuel means 14.7 parts air to 1 part fuel is normally thought to be the perfect mixture for an engine. And if you get leaner than that, it's going to be overheating. Well, that's all misinformation, because it's a half-truth. The truth about the matter is you can go as lean as 20 to 1, 25 to 1, 30 to 1 if you have hydrogen like water gas supplementation or straight hydrogen supplementation, or you have the plasma. And so when people are adding hydrogen cells, basically commonly ducted water electrolysis cells, as a fuel supplement, the gain is not coming from the hydrogen exploding and pushing on the piston. There's not enough to do that. What that water gas supplementation does is that hydrogen is very fast and very hot, and that hydrogen ignites from the water fuel cell, and it flames really fast into the it detonates into the rest of the combustion chamber, and it more thoroughly ignites the rest of the fuel that's there that a normal spark can't. And so you're getting more power out of the same amount of fuel, or you can go in the opposite direction of leaning it out, and you are able to thoroughly combust an ultra lean mixture, because the plasma ignition and hydrogen can extend the lean burn limit, which means you can go to 20 to 1, 25, 30 to 1, and you can actually experience a temperature drop of over 100 degrees on an engine, which is quite contrary to the claim that you're always going to have overheating. So to go leaner and actually go cooler is proof that you have increased the thermal efficiency of the engine, and that's what this project is about. So anyway, next step is going to be the well, first I got to mount this. I got to make some connections there and mount this to the ignition key, and then I'll be putting on the diodes. So that may be a project for tomorrow. And so anyway, you can see how easy this starts. Just as soon as power's on it, that starter, and it turns, that thing starts. So this is how I eventually mounted it. I don't know if this is going to be the permanent place, but it works. There's a little bracket there. And it's got a hole on both sides, so it's just mounted in those two. Got to tighten it down a little bit, but so whatever that little bracket thing sticking out is, 2 holes almost lined up is close enough. So I got pretty skinny screws in there and fender washer on the back side, and so that's what it's going to mount for now. Worked perfect. So next step is to add the modification for the plasma. Okay, so now we're going to put these high-speed, high-voltage diodes on the ignition so that we can have the plasma. This is the positive terminal of the ignition coil. This is the negative. And this orange and black wire from the MSD, from that unit, are the positive and negative. Now this is going to be ground, and it's going to be positive, which obviously means it's positive from the capacitor. So when the MSD switch is on, the positive from the capacitor is connected here, and it's probably triggered on the negative. And so what we want to do is be in contact with the positive of the capacitor go through a diode, and the diode is going to be pointing in the direction. It's going to be based on what the high voltage polarity is, which I believe is negative, which means we reverse the diode, and then through the diode to the top of a non-resistor plug inside the boot here. And so when the high voltage sparks, that capacitor can actually discharge across the gap even if it's low voltage, because it doesn't see the resistance of the gap anymore, because the high voltage has ionized it and has made it conductive, and we get the hyperfast negative resistance effect where the capacitor has an accelerated discharge beyond what's normally possible, and that disruptive discharge right there will thoroughly dissociate hydrogen from any molecule that it's touching or in contact with, like a hydrocarbon molecule from the fuel, or H2O from water, vapor in the air, or water injection, or any of the atomic or molecular species coming out of a HHO cell. Plasma will ignite that hydrogen. The hydrogen will have a fast flame propagation speed, will penetrate the rest of the combustion chamber, and will more effectively ignite a lean fuel-air-fuel mixture beyond the normal lean burn limits. So test it out. Okay, so here's a plug that I have clamped to the top of the valve cover, just for a good ground. And this particular plug is a NGK V-Power. It's non-resistor, so it's around 4 ohms or so. And right now the diode is not connected. And so what I'm going to do is I'm going to start it up so you can see what just the regular MSD spark looks like. And then after that I'll hook the diode up and we can see what the plasma looks like in comparison. Okay, so that's a capacitive discharge spark, what you would typically expect in a MSD. So what I'm going to do is I'm going to pause it, I'm going to hook up the diode, and we'll test it again. Okay, now I have the diode hooked up and we're going to see what the plasma ignition looks like. And keep in mind that the capacitor for the regular MSD with the regular spark that you saw is going to be the same capacitor with the same joules of potential energy, but I'm causing a negative resistance effect for that to discharge at an accelerated speed, compressing all that potential, all that energy into a smaller unit at a time, which is going to massively crank the power up. And that's how you can get like megawatt impulses from very small sources of potential energy. And it's also a not just an enhanced spark, it's a completely different plasma phenomenon. It's a high-speed disruptive discharge. It's actually a little bit more sophisticated than the typical disruptive discharge that Tesla was using. And so this is the impulse that will instantly dissociate hydrogen from a hydrocarbon molecule, or even from water, or anything else that has hydrogen on it. And so we'll go and start it up and we'll see what the plasma looks like. So you can see really there just is no comparison. I'm not increasing the amount of energy that I'm putting into the ignition compared to the regular capacitor that's already in the MSD. And so this is that's a basic demo just to show what you can do when you utilize so-called electricity in different ways than are conventionally thought to be possible. But in any case, that's the demo right there, and so what I'm going to do is I'm going to go ahead and hook all that up to all 4 spark plugs in the engine, and this 1977 Datsun 620 pickup with this L20B right here, which is a fairly new rebuild from somebody that I bought this truck from, and it will be a plasma powered Datsun pickup. So after that, that will conclude the ignition modification, and then we're going to be looking at putting on some hydrogen supplementation, tweaking the jets on the carb, because with this plasma you can actually run way leaner than the normal lean burn limits. And so 14.7 parts air to 1 part fuel is normal. We can go 20 to 1, 25 to 1, and we'll actually see the engine temperature drop, especially if there's a little bit of water vapor injection in there. And so anyway, we'll hook all the diodes up. Okay, I have it hooked up right now. I'm using different diodes now. These are smaller ones. The big ones I showed you, these kind of things used to be up to about 25 bucks a piece. And what I have now, you can get these off of eBay for about $2.50 a piece, which is, you know, it's a 90% reduction in price compared to what they used to be. They're just getting so cheap, it's crazy not to get to do this. And so I am using 4, so there's 1 diode per plug. And so what I have, you can see that green wire there, that's coming from the positive of the ignition coil, because that's connected to the positive of the capacitor and the MSD. And then that's going into one side of the diodes, splicing into all 4. And then all 4 diodes, 1 diode is going to the top of each plug and underneath the boot. And so what I'm going to do is start it up and see if it'll start. So it started up just fine, runs perfect. When I give it gas right off the bat, it kind of bogs a little bit. I have to do some work on the carburetor and the intake, but other than that, if I just slowly kind of rev it, there's no problem with the ignition. So this is probably the first ever old Datsun with the plasma ignition on it. And so there you have it. So I'll zoom in here a little bit. You can kind of see this. Not sure where I'm going to mount this yet, but this is the green wire coming from the positive of the ignition coil, going in through all 4 into one side of the diodes, the other side of the diodes. Each one is going to their own plug, and you can see how I kind of wired that in there. It's just kind of going underneath. That's about all there is to it. And so what I'm going to do is somewhere in between here to connect and disconnect the diodes, probably right here, I'm going to insert some type of maybe 12-volt latching relay. So I just click a button, and I'm only going to turn the plasma off or on when the engine is off, because I don't want it to try to spark through the switch. So if the car is off, I can hit the latch relay in one direction, and it's going to open a circuit and keep it there, and the latching relays won't draw power after it makes contact. And to either engage or disengage, and I switch it in the opposite direction, and it'll move to points to the other way, and we'll open it up. And so that'll probably be the way that I can simply, you know, turn the plasma off and on and do comparisons that way. 12-volt latching relay. So anyway, that's the plasma ignition. You could see that the plasma one is completely different from just an enhanced spark. It's a completely different thing. There's absolutely just no comparison. And so my next move is going to be probably mounting this stuff better, and I'm going to modify the gap on the plugs. I'm going to open up a bit. That'll give me a higher voltage, initiating voltage. I'll discharge the cap across, and it'll also speed up the cap discharge. And that'll compress the discharge into a smaller unit of time, so the power will go up even more. And then I'm set for either water vapor, HHO injection, anything that I want, and I'm going to be able to lean out that Weber carburetor right there. So anyway, work in progress. Ignition is done, successful, it works. This is about the lowest resistance ignition system you're going to be able to put on a Datsun like this. And here's how you do the diodes. And this is all explained in, if you want to go to energeticforum.com, you can see my old threads called water spark plug. You just search for that and you'll see all the information. It's all freely posted there for anybody to read. You're going to have to sort through quite a few different posts. Otherwise, you can get my book and video presentation on ignitionsecrets.com, and that'll basically explain everything from beginning to end on what this is all about. So anyway, hope you enjoyed that. Hopefully we'll see some other old car enthusiasts, especially some guys with some old Datsuns, putting this on there. It completely obsoletes every other aftermarket ignition system out there. There is no comparison between all these other high-performance ignition systems and my method for the plasma ignition. This just blows them all away. And you can see visually it's completely different than anything else out there will make. So there you go, L20B with plasma.